So me and my partner, we're going to explain to you guys how to use a multimeter and what it's used for. So a multimeter is a very efficient tool as it allows us to measure the resistance in ohms, the flow of current in amperes, and the electric potential difference in voltage.
Its usage is very beneficial when we're trying to repair electrical malfunctions. Multimeters can be used to assess an internal resistor of a battery or a CPU's motherboard, but in this case, we're using multimeters to measure the voltage across 3 resistors and the intensity flowing through each respective resistor, all organized in series.
For this experiment, we're going to use the following equipment. Over here, we have the power supply. This is the on-off switch, and we're going to set it to 5 volts using this knob. Over here, we have 2 multimeters. One of them we're going to use to calculate the current, so the intensity of the current in amperes. And over here, we're going to calculate the voltage. Here, we have the Omni board, and we're going to use the first 3 resistors from the top left corner for this experiment. We have several wires over here that we're going to connect to the power supply, to the multimeters, and to the Omni board.
In order to use the ammeter properly, we need to connect one end of a red wire to the positive output of the power supply and its other end to the input A, signifying amperes of the ammeter. Then, we need to get another red wire and connect one of its ends to the output COM. The current flowing from output COM flows through this wire and goes to the first resistor. Then, the current from the first resistor goes to the second resistor through this black wire. Then the current from the second resistor goes to the third resistor through this red wire. Then the current from the third resistor goes back to the negative input of the power supply through this black wire. In order to measure the intensity of the current flowing through each resistor, we need to break the circuit. Now, in order to do that, we need to disconnect this wire, which is connected to the power supply, and connect it to this wire, which is connected to the amperes A of the ammeter. And now we need to connect this wire, which is connected to COM of the ammeter, to the first resistor. Now, we turn on the power supply. Now, we can read the intensity of the current flowing through the first resistor. We turn off the power supply and rebuild the initial circuit. Now, in order to measure the intensity of the current flowing through the second resistor, we need to do the same process. We disconnect this wire and connect it to the black wire again, which is connected to the ammeters, to the A of the ammeter. And then we reconnect this wire, which is connected to the COM of the ammeter, to the second resistor. Now we turn on the power supply again, and we can read the intensity of the current flowing through the second resistor. Now here it's negative. It means that the wires are connected not on the right conformation, but we need to take the absolute value of that and not worry about the negative sign in order to find the intensity of the current. Now, to measure the intensity of the current flowing through the third resistor, we need to rebuild the initial circuit. Now, for the intensity of the current flowing through this third resistor, we need to disconnect this wire and connect it to this wire again, and then connect this wire to the third resistor and turn on the power supply once again. Now, we could see the intensity of the current flowing through the third resistor. Now, in order to put it back to the initial circuit, we reconnect the wires as shown in the circuit diagram.
So we're going to take the third resistor as an example to measure the current passing through it. So over here, when I turn on the power supply, we'll see that the current passing through the resistor is 6.36 amps. So the reason to why we emphasize on the word through is because the current flows from the positive terminal of the power supply through the circuit and back to the negative terminal of the power supply. And as we can see, the ammeter is connected in series with the third resistor. That is why the current flows through the ammeter, so it's measuring the current passing through the circuit, and then eventually the current that passes through here will go back to this circuit, and then it'll eventually go back to the power supply, which is why we emphasize on the word through when we measure current. So I'm going to explain to you guys how to measure the voltage across each resistor. So you're going to take this red wire over here, and you're going to connect it to the input of COM, and you're going to take the other end of the wire and connect it to the left-hand side of the first resistor. And then you have this black wire over here, so we're going to connect to the output of V and connect it to the right-hand side of the first resistor, over here like that. So then we're going to turn on the power supply and we're going to calculate the voltage across the first resistor. So in this case it's 0.63, but we want more significant figures, so we're going to decrease the range a little, so we're going to change it to 2 over here. And you want to make sure that this arrow over here is pointing towards the DCV side of the voltmeter. So the voltage across the first resistor is 0.642. And now we're going to connect. Now we're going to measure the voltage for the second and the third resistor. So I'm going to turn off the power supply, and I'm just going to simply take these 2 wires and connect it the same way as I did for the first resistor. And I'm going to connect it over here to the second resistor. And I'm going to turn on the power supply, and I'm going to see what I get as the voltage passing across the second resistor, which is 1.4144 volts going through this, going across this resistor. And now I'm going to turn off the power supply, and I'm going to do the same thing for the third resistor. Connect them like this. I'm going to turn on the power supply. And now you can see that there's a -1 over here. So we have to increase the range. So now I'm going to change it to 20. And so now my voltage is going to be as 2.96. So if you guys notice, there's been a minus sign. You guys could have noticed that there's a minus sign in the third resistor and in the first resistor. Basically what that means is that the way that we had connected our wires is not correct, because if we simply just change the way we had connected our wires, if I took the black wire that came out from the V and I connected to the third resistor on the left hand side, and I took the COM and I connected to the right hand side of the third resistor, I get a positive. So basically the negative sign that we get over here is insignificant. It's not that important. We just want to know what the value we get over here. So the term across the resistor is used when it comes to the equation Ohm's law, because it basically signifies that the voltmeter needs to be connected in parallel across each resistor. So over here it's connected in parallel across each resistor in order to calculate the electric potential difference between 2 points. So these are your 2 points. And the left hand side would be your electric potential initial, and your right hand side would be your electric potential final. So in order to calculate your electric potential difference, you'd have to do your electric potential final minus your electric potential initial to calculate your delta V in Ohm's law. And that's simply how you calculate your delta V for each one of your resistors. And that's it.
Now, let's observe the following chain reaction of dominoes, which represent the flow of current. Let's assume that the resistors are the zigzag patterns. The higher the resistance, the longer the zigzag pattern is, and the more difficult for the current to flow back to its normal flow.